So, so last time we were looking at some code, and I just posted it here. So if you look at the code in this Canvas folder, you can take a look at, this is where we stopped last time. This one file right here. Let's see, this is what the file does when, this is how it renders. Just got this, this green dash border around every element. That green dash border, where does that come from? It comes from this right here. See this star? Match everything. Border width 1, color green, and make it dashed. There it is. This is the green dash. We have a canvas here. In the canvas, we wrote this box and some text. Here's the canvas. The ID is FPS, frames per second. I was going to put show frames per second in there, but I changed my mind about that. Let's call it something. Let's call it a game. So this canvas, we're going to make it a game. This is the canvas element. I give it some initial, width and height. And maybe that's not quite big enough. Let's get a little bigger. Bigger. And so here we get a reference to the canvas, there, to this game. What do you call it? It's a canvas element. And then we get the context from it here. And then we wrote a function to create text. And this is to create a text object. So you see this let O equals, so I'm making an object. I'm using O as a variable to refer to this object that we're creating. So we want to create a text object for rendering text. Well, look at the arguments. There's a string, the text string that needs to come in. There's the X and Y position of the string to render. There's the color of the string. And then there's the font to use. So this is passed into this function, this create text function. So we have a object O here, set it equal to an object with those attributes in it. And then we attach a draw function. And when this draw function is called, T is passed in. And when T is passed in, what we do here is set the fill style here, that we set the color to the fill style font, and then we call fill text to print that. And so once we attach this draw function, we return the object here. So this is one way to manage objects in your app. I'm going to show you a more traditional way now. And here's another one, create box. So this creates an image, this creates a text object. Let's create a box object. See, this is the XY coordinates. This is the width and the height and the color of the box. Just a solid rectangle. There it is right here. That's the draw code. So these are the functions kind of like the factory methods to create box objects and text objects. And then down here, we call those factory methods to create those objects. So here we create a text object that says hello. Create another text object says bye bye. You can see this is the XY locations. And then we have the color here. And then we have the font size and type. And then Then we have a blue box. It's similar, creating a box. And then we have this, these are like our kind of like game objects. They just have a draw method that takes a time t. And then here we have the main loop. And the loop is going to depend on the time. It's going to use time. So performance now is similar to, you could do something like this. We create a date object, and then we pull out, I forget what it is, to time or something like that, or seconds, or total. I can't remember that. Let me look at the JavaScript. Anybody know? Get date. Here it is. Get milliseconds. Oh no, that's only the fraction of a second. Here it is. Get time. Returns the number of milliseconds since January 1970. So that's normally, we call that get time there. And, that's the T here. I'm going to call this, let me call that, let me call it T1. Yeah, T1 is that, and T2 is this. Where is it? Performance.now, right? It was performance.now, I think. I think they give the same thing. Is that, where's the, oh, here it is. Yeah, here it is, performance.now. So these both give milliseconds. T1 and T2 should be similar. So let's do, this is T1. Oh. Let's do T2. So I believe these are going to be very similar. They're going to be similar. Let's see. Open up the JavaScript console. Reload the web page. There's T1, and there is T2. They're totally different. T2 is 23. T1 is some large number. This must be the milliseconds since the beginning of since the thing was loaded. That must be it. So these are different. So we're not using the date object here. We're using this performance now. If you look here, see this? Let's look at this. This request animation frame. I think these are going to be, let's do it like this. This request animation frame. Let's call it request animation frame. And we pass in our function. And this, remember that the function gets called with milliseconds. So we're just going to call it once here. So here we're calling it here. Let's see, so we're going to call it. There we go. Passing in this function into this call to request animation frame. T1, this is T2, and let's check with these millis. I think millis is going to look like this T2. Performance now gives this one, and this is the date. that one. There it is. So, oh, look at that. See, I reformat the code and I see the mistake right there. That's a benefit I noticed when you put things, try to neaten things up a little, or just play around with it, refactor, change names. Once you do clean, I notice that when I get in the habit of cleaning, I find bugs, before testing. When you find a bug during cleaning, it's so much faster to fix than trying to find a bug during testing. So cleaning is a very useful activity to make your coding faster, not slower. So I believe that performance now and millis will be similar. Let's take a look. There it is, millis 20, performance now is 26. Well, they are different still. So I don't know where the difference is coming in. So the millis here is showing 20 milliseconds. That's pretty fast, right? This is 26, 27 milliseconds. So these, the clock, I was reading about this yesterday. This clock, there's an attack that can be performed if you expose a high precision clock to the JavaScript, then there's it enables some sort of attack. And I don't know how the attack works. I didn't get into the details. But because of this threat, on purpose, they add some noise to the time value. So even though this performance now gives an accurate value, it's not, on purpose, it's kept from being as accurate as it could be. So you see some differences here. It's a difference of 7 milliseconds or 6 millisecond difference. That's pretty small, 6 milliseconds, 6 thousandths of a second. So that's pretty close to the same value. These are probably meant to be the same thing. And take a look. This in can I use? I think there's some discussion in can I use on this. So the performance, right? The performance API. The performance API has a number of different things in it. There's the now function, right? And then there's the other aspects of this API. But let's look at this now function. So it's supported on everything. Opera Mini does not support it. Usage of 1.43%. It's not too bad. Oh yeah, and then these other browsers as well. These don't support it. These don't support it. I don't know how much. That's a lot, 3%. 1%, 0.20, 0-ish. So you're losing some people here by using this. Look at this. In Firefox, the accuracy was reduced to 20 microseconds. Well, microsecond. Is that a milli? Is a microsecond? Micro. Is that a millionth? What's a microsecond? How many milliseconds in a microsecond? I mean, how many microseconds in a millisecond? Is it 1,000 microseconds in a millisecond? It says 1,000 milliseconds in a second. How many microseconds in a millisecond? I think it's 1,000, but it could be 10 or 100. 1,000, there it is. So 20 microseconds is 0.02 milliseconds. So that's really small. So that's interesting. Let's see if there's any feedback here. Firefox 60, microseconds. It's like they're increasing the decreasing the accuracy. The accuracy was reduced to 20 microseconds in Firefox 57. And in 59, it was reduced to 2 minutes. It sounds like it was increased to 2 milliseconds, right? The accuracy was reduced. That's right. It's reduced to 2 milliseconds, so they made it worse. And then in Firefox 60, they increased the accuracy by reducing the range down to 1 millisecond. That's interesting. So we got to be careful about what time values to use here. Maybe what we could do here is, instead of setting t like this, let's initialize t this way. So we set the, we have t set to 0, and then we call this request animation frame, pass in our function, and then just set t equal to the millis that we get back from it. And that should do it. But we want to divide that by 100, by 1,000. I'll put that into seconds. So there we go. Maybe that's better than calling performance now. Just call this thing once to set that. And then after we set that, watch this. After we set that, we can start the loop. So we'll start the loop at that point. Let's do it here. So this would be, so we got some sort of loop function here, right? I don't know, where's the loop function? This is draw millis. This is the loop here. That's the loop. So we call this request animation frame. We're passing this callback function. It just sets our t to initial value and then starts up the loop. Here's the loop. And then we have, maybe I'll leave a comment in there. The elapsed time, dt is the elapsed time since the last frame. So I'll just leave it like that. So we take the, this is the millis get passed in here. So divide by 1,000 to convert to seconds. Let's subtract off the old seconds up here, right, which we set initially to get things going. Clear the viewport here. And then draw the game objects here. So we call draw on these guys. This shows something moving. Let's take that out. But then you have to keep the loop going. So you gotta call this again at the end. There we go. And here's that function. So here we have the, let's see, 1, 2, 3, 4. I don't know the best place to put it. Maybe this looks good over here. See, I want to see the t here when we initialize it to 0. And then we define the loop function, and in here we use t, so we say, oh, it's a locally scoped t. And then down here we initialize t. It's a little confusing, but I think it's okay. Let's see if things are still working. Looks okay. Now, let's rather than working in the HTML file, let's go to a separate. So we only have this one file in here, index.html. Let's copy it. We'll call it say game.js. I'm going to change it a little. I'm going to call it a.js. A is for application. And I'm going to get rid of this. And here's the script. We're just going to put the script in here. It's a.js. And then in here, we can load the script. This will be a.js. Just to keep things simple. Split the file up. And we might want to clean up this HTML a bit. This is an HTML file. There's a head section. And we close that head section. There is a body section. We close the body section. We close the HTML element section. And that's what that looks like. Should all be in the head. I'm going to leave it like that. I'm going to cheat a little on the indent. I don't like too many indents. So I'm not going to indent this element. Just to make this a little more abbreviated, it's easier to read, or less stuff going on anyway. And this border will be 1px green and dashed. It actually can understand that. And then we have a body looking like that. Everything's still good to go. And now we can just focus on this this application here. So I want to show you a little bit differently how to do this creation, this text creation. I'll modify that a bit. What we're going to do is make a constructor for the text class. And this, let's do it like this. I want to put it in I'm going to create an application object. I'll do it like this. Let's do it like this first. Here's the text constructor. And it just takes the same arguments as this. And we need to populate the object. So what we do, this constructor here, we're going to continue saving these arguments. The arguments that get passed into the constructor here. it'll look something like this. It'll look, when we use this thing, it'll look like this. It'll look like, something like this. You know, maybe we say hi, maybe we're at 100, 100, 160, say, and the color is going to be, gray. Hope that's spelled right. And then that should be a string. Is it that spelling or that spelling? I don't know. And then the font, it'll be like 12 pixel sans serif. Let's see if that works. I'm not sure the spelling is right. So that's how we create a text object there. Maybe I'll do it like that. So I use the uppercase T for constructor name. I use the lowercase t for a variable to refer to an object. And so this is how you would use this. It would be down here somewhere. I don't know where we'd put it, but we create it. We call new text here, and this is what text looks like. See, so we're passing in high, 160, gray. We're passing in text, X, Y, colors, and we have to save these as attributes of the object that we're creating. So when the constructor runs, when the JavaScript constructor runs, this is a pointer to the object that you're building. So, this is an empty object, and here I'm just attaching properties to this object that we're building. I'm just saving the arguments that are being passed in. So that's how that looks. Now, the draw. What do we do with this draw function? Well, we're going to use prototypes for this. So this, when we define this function text, you'll see that that there's this function has a prototype field. Look at that. So that's going to exist. So I can assert that that exists. But this is not normal for if we just create a new object like this, and it won't have a prototype field. So it gives no assertions. So if this was not undefined, just to show you what that would look like, then we get an assertion here. So just to show you that this is creating an empty object here. It doesn't have automatically a prototype field set to it. But text here, that's a function. So when you define a function, functions get a prototype field because all functions can be used as constructors. When a constructor is used with the new operator, then that new operator looks for the prototype field. Anyway, that's sad. And so now that we've defined this text, it has a prototype field. That's where we attach the functions. For instance, the draw function. The draw function takes a t here, right? And I might change it to update, actually. I don't like the name draw. So there it is right there. I mean, it's just 3 lines. says we set the fill style. There's font. I know there's font in there because we set it there, right? Oh, but what happens if the user calls text without a font specified? Then, like you could call it like this. Watch this. Let's call this T1, and then T2, and then I'll just make that a by, and that's say 260, and that's orange, and then this will be, and here, let's suppose we leave out the, leave that out, see. We call the text constructor without the last argument. So when this text constructor runs here, the font is undefined. So we're setting this dot font to undefined. Yeah, I'm going to leave it like that. We need to do sort of like this lazy evaluation of font here. So here, this dot font, this may actually be undefined. So I could do it up here. I could do, you know, font. If font is undefined, then I could just put a, you know, I could just put a default in there like that. And but then if we, yeah, then we could change it. Actually, that's a good place to put it. We'll just put it right there. Let's just put it right there. Oops. So I know that this font will be always defined. At a minimum, it'll be this. Of course, you could pass in something that doesn't make sense, so that would crash it. And same with the color. If we omit the color, let's give it a default color. Instead of, let's call it T3 here. And I'll just say the word house, for whatever reason I'm saying that word. And then put that in 300, and let's omit the color here. So now we got to do the same for this color. We want to default for the color. Let's do that. Let's make it a black. Excuse me. Now I'll use hexadecimal numbers for that. Make it pretty so it's easier to read. No, they could leave X and Y out as well. I mean, we could put defaults in for that. So why don't we do that? Let's put a default in of 0. I don't know if that's important. Maybe it's better not to do this, not sure. And the text. I mean, we could set text to, yeah, I mean, we could do that as well. We could set text to, say, empty string as a default. Not sure that that's useful, but not such a bad idea. So everything is a default now. See how that works? This is called, this is an OR operation. And I'm using what's called a short circuiting. So let's suppose you passed in a 3 for the Y. Then you would go 3 or 0. What's 3 or 0? What's 3 or 0? Let me put it back in there. Let me just do it right in here. So 3 or 0. Anyone know? It's 3. 3 or 0 is 3. Undefined or 0. What is that? That's 0. False or 0 is 0. See, when the system sees this OR operation, it looks at the first argument, like this 3 here, and it says, is that argument a true value or a false value? And if it's a number, it's like, oh, well, it's not a Boolean because he put a number there. Okay, so then we got to go back to our table. It's a number 3. Well, that's true for us. So it's true or something else. Well, you don't have to evaluate the something else because it doesn't matter what something else is. True or something else is going to be true whether something else is true or false. So the short circuit evaluation is to take the first argument of this A or B expression and use that A as the value of the expression. And notice it just renders a 3. This is a logical expression, 3 or 0. And it evaluates to a number because as I explained, the result of the expression can be determined just by seeing that the first argument is true. There's no reason to evaluate the second argument. And what the JavaScript language does is it keeps the data type the same for that first argument. It just lets the expression evaluate to that value. So I'm doing that here. If y is passed in here, then it'll have some value, and that'll be taken for this y. But if y is omitted, then y will be undefined, and undefined is interpreted as false. So if the left-hand side of the OR operator is false, that means the right-hand side must be looked at. And actually, JavaScript doesn't do anything fancy. It doesn't actually evaluate the right-hand side. It just says, well, the left-hand side evaluates to false. So the whole expression will evaluate to the right-hand side, and that's it. I don't even need to look at the right-hand side. So the right-hand side evaluates to 0. Anyway, that's what's going on there. That's a lot of talking. Sorry. So here's the draw function for text, and let's see if this, now we're replacing this create text deal here. I'm going to take this out now. Notice the factory function returns O, see? But we don't need to do that now because we're using this. We're going to use this constructor function with a new operator. So we just save the return value there. And so this is part of our game code in a sense here. So we get these things, and then we same thing for the create box. We can do the same thing. And so taking this out, we'll leave the box in there. I'll take the box out. And then the loop, here's the loop. So we have T1, T2, and T3. There it is. Let's watch that happen. There we go. Hi, buy, and house. It doesn't look that good. They look too small. Why are they so small? This is 12 points sans serif. What if I did 22? Oh, that's bigger. maybe as the default, I'll call it 24 as default. How's that? And I'll make this high. Make that I'll make that 52. There we go. Anyway, we got this all working. I demonstrated that. The same thing with create box. We could do the same thing. Let's go ahead and do that with the create box. I'll show you how that works. So we just go ahead and make the box constructor here. Here's the box constructor. Well, there's the X, Y, W, H, and color. It's similar to these. I'm gonna copy these and paste it down in there. So we got an X value, a Y value, a W value, an H value for the height, W for width. We'll make it 50 by 50. That's the default. Maybe 100 by 100. Better. And I changed my mind. Let's make it 150. I don't know why. I just do it like that. Here's the default color, black. I guess that's okay. There's no font. And this is from our old system. So that's the constructor. What about this draw method? It's going to look like this for the box class. So the box is a function, has a prototype field. Set the draw method. There we go. So we define the constructor function and we attach functions to its prototype. That's the procedure to make classes in JavaScript, or class-like objects. These functions, object functions, I mean constructor functions, right? You know, define the constructor function, then attach functions to its prototype. And then you can do things like, creating new things like this. So we have the box.draw dt. And we got to create that box though. Where do I create the box? Here. I use new box. I'm going to give it say 200 X and Y. Width is 200. The height is 20. And then the color is brown. There it goes. Now, just to get things organized here. Kind of like we've got this, this is like specific to the game. You're going to create a box. It's kind of like the level design. And then you have the generic infrastructure behind everything. That's like this loop here. Although we hard-coded these objects in that loop, but we want to make the loop kind of generic. We don't want we want it more flexible. We don't want to hard code the draw calls to draw inside the loop. So we would normally do something like this. Let's do it like this. So maybe we'll, what's the best way to do this? So we're going to have a, some objects here. So we'll do, we'll call them the OBJs, make an array of objects. And we can iterate through the OBJs. And call the, so we get a particular OBJ here. I'll say that's the OBJs of I, right? And then we take this and then call a draw on it. I want to pass in DT, right? There we go. So we go through all of them. We just have to put these guys, instead of calling these individually, we put them, we iterate through these OBJs and then call their draw method here. Let's, we just have to put these things on the OBJs, right? So this here, I'll do that here. So these are these game objects here. We create these things. T1, T2, T3 in box. But we got to put those on those OBJs. So it's OBJs dot push. That's how to add it. OBJs is empty, an empty array. We use push to add things onto it. So this will be the box. And this is 3. That's 2. Okay. Let's change the brown to gold. Work. All right. So the new architecture is good. Normally we'd see, once again, this all kind of mixed up here. This is like very specific game code versus this is like generic stuff, this loop. So, and the app is going to get kind of big, so what we do is create an application level object. So window is the attributes of window are considered part of the global namespace. So let's define a variable A that's in this global namespace. We'll call it A for application object. Application object. That's what I call it. So everything's under A. And then rather than letting these things float around, well, it's okay. We can leave these out here. It's fine. We're probably going to need to add them to A though. And then we have this text. This is all good. And but these OBJs, if we want to put them in directly in that application object, so the code outside of A can get at that. And then we're going to need to fix this up. these OBJs are in the application object. And now watch this. Now we can go to this index here. And I put everything right there. So I'm putting this code in inside another file, inside index.html. Not that I want to leave it there, but that's what's going for now. Somehow that got off. Close off the function, and I call it. I had trouble making this work the other day. This OBJs wasn't defined, and it had to do with putting it in this function. And I haven't gotten to the bottom of that. Let's see if this whole thing works. Probably not. Better keep the console open. OBJs is not defined. Line 47 in a.js. Line 47. Look at that. See that? It's a.objs. Same with this one. Oh. There we go. Clear that. It works. Well, we got nothing is being viewed. How come nothing is rendering? Something is not happening. So this is the loop here, right? So this request animation name is the loop running. This is the OBJs. And then here we push onto the OBJs. What's missing? Oh, this text is not defined. This text is external. See, so I got it. There's text and box that must be part of the browser API. Text and box must both be defined. You know, like if I do box. Well, that's not defined. So let's get this. I don't know why it's not giving me an error message here. So I don't understand why that. Oh, I see. Sorry. The script here, it wasn't working. I didn't close that script tag. That must be it. But this was a problem. Now let's see, just to show you what that would look like. Take that out. See, a.text is not a constructor, but that's in 20, line 20. But it didn't mind this one here. So I don't know why. Maybe that's part of the API. How about box? Let me look at that. Yeah, I didn't get to that error. It's all right. So let's get the let's get this box. This box here. A.box. I'll make it go like this. We could leave it just like this. And then at the end, I could do something like, a.box equals box. We could do that. And a dot text equals text. That's to get those on the outside. That should do the trick. There it is. So I'm not sure that's what we want to do though. The other way to do it, either we do it like this and keep box and text sort of locally scoped inside here. Maybe that's the best way to do it. The same with OBJs. We could do the same thing with OBJs. Watch this. So we could just do const OBJs. See that? And then this, and then we could take this out here. If this is the style we want to use, I wouldn't mix styles. Just use one style or the other. So we got to do the same thing here. So it's a dot objs equal objs. Is that how we want to do it? This is not the order in which this is how we define them like that. Let's see, everything's good. So this is one way to do it. This is so we just attach. It's kind of like a module, and we're just these are locally scoped identifiers, and then what we're doing is just giving them external scope by attaching them to this application object, pointers to those. Let's go ahead and keep going. So now we got this working. Let's get some. I was thinking about getting like a game here, and let's have a gun, and we'll fire an object. We'll fire the box, something like that. So do something like this. Let's do this. So here we're going to push, say, we'll push a player, a shooter, called a shooter. And let's do that. Let's get rid of these things. And let's create a new, I guess we just create the shooter. Like that. I'll go ahead and create that thing. And how do we want to do this? Maybe let's do it right here. Let's create a new shooter right here. And then, we push it here. Now I get a better idea. Let's do it like this. Let's, a missile. And we'll do it like this. So, we just create it right here. We don't have to define it like that. We'll just do a new missile. And let's let's go ahead and create that missile. Here's the text. This is the box. And then just do it like this. So now we have the missile. I guess we can give it an initial. Now we'll just won't do anything right now. Just do this, yeah. And then let's do this dot missile. No, just do it like this. This dot box. We'll create a new box. This and nah, I gotta do it. Just do it like this. Create the missile, and there's an X value. We'll set it to 0, and then for the part of the draw, oh, this T, by the way, this is not a real T. This should be a DT, I think. Isn't it DT? Let me find a loop here. It's going so fast. It's DT. I call it DT here. Yeah, pass in DT. That's the for it's for the time of the current frame. So this should be a DT, not a T. We just ignore it here, so it doesn't really matter. All right, so and then this missile, let's see. The missile has a draw function, and we give it a color, which is say, we'll make it black. We fill this rectangle here. This is X and Y, and this is the width and the height. Let's put a number in there, say 50 by 50. Now I'll go width and height, because we're going to need that. So this is the height, this is the width, this is the Y value. Make the Y value equal to say 200 or 100. And the width is going to be 50, the height is 50, it's a little box. And then, so here we do this fill rect stuff. And then we're going to have, we want to move it a little bit actually. So we can do this dot X equals, well, let's just leave it like this for now. Let's see if we got an application running here. Missile's not defined. It's a dot missile. Has a dot missile. And then you got to come down here to the bottom. This was our strategy here. shows the how we're exposing things to the outside here. So then let's give it a try. There it is. Now we're going to give it some movement. There's the missile. So we're going to have the so that DT. So we'll do it like this. We'll do this dot x plus equals this dot x times a rate, a speed, say per second, say 100 pixels per second times the number of seconds. That's the number of pixels to move. Oh, see that thing? It's not moving. So this draw, why doesn't that draw? Why doesn't that work? Why doesn't that work? So the draw, so this dot x plus equals, I don't know why it doesn't give me an error message on that. There we go. It's plus equals. Equals plus, I got no error message. There's our missile. Make it funner. Yeah, that's funner. Okay, now we have a user input. You know, I'm thinking that maybe we could do something like the user can. I was thinking the user put like a gun here. I was thinking the user could tap somewhere, tap anywhere, and then the gun will have to move at its rate and lock into that row position, and then fire the missile. And then we'll have things like falling down here as we try to fire the missile at different speeds. I don't know, just to play around with it. So once again, we got this, and we're getting this thing sort of set up. We got this application object now, and we're hiding things to a certain extent, and breaking the code up between kind of like gameplay code and engine level code. Just trying to split that, make that division there. So we're going to have to stop here and maybe continue next time. Just go ahead and try to build that out next time.